Okay, we're on to rule number 4. This is the fourth one out of 7 total, but we did already cover number 7, rule number 7, along with rule number 2. Rule number 4, what is this? Okay, so how do you find the derivative of a sum of two functions or a difference of two functions? What's the rule for it? You simply have to find the derivative of each, that's it. And then either add them or subtract them accordingly. So you can find the derivative of u separately from the derivative of v, and then you either add or subtract depending on what question you're dealing with. So as an example, let me go straight to example 1 from the textbook, which I copied here. If p is defined to be t to the third power plus 6t squared minus 5 over 3t plus 16, how do you find the derivative of p with respect to t? Notice that we're dealing with the sum and differences of something that could be considered a function on its own. Okay, so we have a sum of t to the third power plus 6t squared, then we have a difference of that answer minus 5 over 3t, and then whatever that answer is, we're adding to 16. Okay, so you're dealing with the sum and difference, okay, or you don't have to do it in that order, okay, in any order is fine. But if you want to find the derivative of this with respect to t, you will simply find the derivative of each term, okay, or each function, okay, depending on how you see it. So t to the third power, you can find the derivative of that using the power and the constant multiple. Oh no, that's just a power rule, I'm sorry. So that'll be just 3t squared plus, and then I want you to find the derivative of 6t squared using the power rule and using the constant multiple rule. That becomes 12t. And then that next one, negative 5 over 3 is, okay, so is multiplied by t to the first power. So using the power rule, the derivative of that will simply be negative 5 over 3, because t would have t to the 0 power, which just becomes 1 on its own. And the derivative of 16, that's the derivative of a constant value. And someone mentioned in my block 1, that's like 16. You could think of it as 16 times t to the 0 power, which means you can multiply that 0 by 16 to get 0 for the whole thing. So you don't even have to write that. So there you have it. So that's the derivative of p with respect to t. Let's go straight to example 2. Does the curve y equals x to the fourth power minus 2x squared plus 2 have any horizontal tangents? Okay, so let's take a look at that. So how can we find where the horizontal tangents are? Okay, once again, this is a derivative question. You find the derivative first. Derivative of y with respect to x. So you could use the Leibniz notation. dy dx is equal to 4x to the third power minus 4x plus the derivative of 2 would just be 0. So you end up with that. Okay, but for you to have a horizontal tangent, we have to set the derivative to be 0. Horizontal tangents have a slope of 0. So 4x to the third power minus 4x has to be 0. Horizontal line, horizontal tangent, slope is 0. To solve that, we just factor and solve algebraically. You could factor out 4x, you end up with x squared minus 1, and then you could factor more to solve this equation. So 4x times x squared minus 1 becomes x plus 1 times x minus 1. So that's equal to 0. So it appears that we have to check 0, negative 1, and 1. Okay, these are the points. These are the x values where you will have a horizontal tangent. Okay, and then you can check this graphically too. And the point of tangency could be found by using the graph or by plugging in these x values back into the original function. You can find the y value, corresponding y values for these three values.